Greetings, class. This video segment will be about measures of central tendency, also known as measures of typicality. Typicality, the first part of that word is typical, which makes sense because to a large extent, measures of central tendency are all about what a typical what a typical score or value might be within a set of numbers. Before I get into the material related to measures of central tendency and measures of variability, I want to just note a couple of things. First, before you watch this YouTube clip, you need to have thoroughly read Chapter 3 in SPATS. Some of you may have already seen, I have placed Chapter 3 online, just again to assist those who may not have the book yet, but as I mentioned earlier, that will come to an end. So make sure that you have read Chapter 3 in SPATS before you continue with this YouTube video, and also read through a document that is in your week of September 5 materials called Packet Explaining Central Tendency and Variability. So make sure you've done at least those two things before you watch the rest of this video. The first thing is read Chapter 3 in SPATS thoroughly, and the other is work through the document, read through the document called Packet Explaining Central Tendency and Variability. I really want to encourage you to be very, very careful when it comes to doing math. It's very easy, extremely easy to make mistakes when you're conducting mathematics. And that's true for whether you're doing things by hand with pen and paper, or whether you're doing things using a calculator, or whether you're doing things using a high-end, very powerful computer statistical package. It's easy. If humans are involved, there's a chance there's going to be a mistake made. So please, please, please be careful. If you get results that seem strange or wacky, by all means, redo them. Do your math over and over and over again to make sure that you're getting things correctly. Be very clear, be very neat. I really can't stress that enough. The need to be very neat and tidy, if you will, when you're doing math, especially when you're doing calculations by hand. This is another reminder also that when necessary, make sure you carry your math numbers out to the thousandth place. There's a reason why we did that rounding exercise earlier in the semester. So when you're doing some of the calculations that you're going to engage in, you will have an opportunity to use those rounding rules and put those into practice. So make sure that you fully understand those and incorporate the rounding rules appropriately. So make sure you carry, if it's necessary, if it's possible, carry your math out to the 1,000th place. That's three spaces after the decimal point. In addition to being very careful with mathematics in general, I also strongly encourage you to work through all the materials for this week very slowly, very thoroughly, and repeatedly. We're really sort of embarking on a new phase of the class because this is again really where mathematics is going to come into play. So please be very careful. Please reserve enough time this week and make sure you do things as slowly and carefully as is necessary. And as always, of course, feel free to email me or call me at any time with questions. Also, another quick reminder before we get into some of the material from today, and that is a reminder that these YouTube lectures, and this YouTube lecture in particular, is not they're not designed to be a substitute in any way for reading the materials for the week. They are no substitute for working through the supplemental materials. They're no substitute for engaging in the exercise. This YouTube clip is designed. These YouTube clips are designed to be supplementary in nature. There will be some things in these YouTube clips that you can't get other places. Some things that I want to emphasize or overemphasize, or perhaps there will be some additional information, some supplemental information that doesn't appear in SPATS that I want you to know about. I will use these YouTube clips for those purposes, but please do not rely on these YouTube clips instead of reading SPATS and working through the other supplementary materials, because they just won't cut it. They're merely a supplement. So anyway, one of the, hold on. Shoot, my apologies. One of the handouts in your folder this week, it's a document called Symbols with Definitions. That's what it's named in the folder. And it looks like this. And it's got 6 items on it. It's got 3 measures of central tendency: mean, the median, and the mode. And it's got 3 measures of what we call variability or dispersion: the range, the variance, and the standard deviation. So if you don't have this handout, you might want to go ahead and pause this video and then go print that out, or at least bring it up on your screen. So anyway, again, that document is called Symbols with Definitions in your weekly materials. Anyway, just very briefly, a quick overview. When it comes to the mean is probably the most commonly used measure of central tendency. It is pretty easy to understand. The mean, as you may already know from your reading in the materials, the mean is the arithmetic average of a set of quantitative numbers. When I talk about, or when I mention quantitative numbers, what I'm referring to there is a variable that is measured on the interval/ratio level. If you're calculating a mean, you need to be working with interval or ratio level data. Now, I will say that it is not difficult at all to find examples of people calculating means and doing other things that they shouldn't do because they're not dealing with interval or ratio level data. It's very common to see examples of means and some of the other quantitative statistics that we're going to work with calculated from ordinal level data. Sometimes, every once in a while, you'll see a mean that's been calculated from nominal level data, and both of those things are not appropriate. Now, we will at times use ordinal level data during this semester to calculate a mean. However, you will find that I will emphasize, if not overemphasize, the fact that doing so is really kind of a no-no. You have to have quantitative data. You have to have interval ratio level data if you're calculating a mean. The mean has a couple of advantages, or has at least one advantage, which is also its main disadvantage. And its main advantage is that when we calculate a mean, we're using all the data in a set. We're using every single case in that data set. We're adding all the cases together, and then we're dividing by the number of cases in our data set. That's an advantage of the mean. Because the mean uses all the data, that means that we have license to carry that number forward, as you will see, carry that number forward into a lot of other calculations that are very useful in the world of inferential statistics. So again, in sum, the main advantage of the mean is that it uses all the data. Here's the main disadvantage of the mean. It uses all the data. And why is that a disadvantage? Well, that's a disadvantage because that means that the mean as a statistic, this first one right here, the mean as a statistic is sensitive to outliers. That's probably the biggest disadvantage or liability of the mean as a statistic, is that it's sensitive to outliers. So for example, I saw a news article the other day that supposedly the oldest man in the world was discovered, and he was 147 years old. That's pretty old. I'm not sure I would even want to live to be 147 years old. And in fact, this particular guy seemed kind of sad. As he said in an interview, he had buried his children, he had buried his grandchildren. It's just amazing to think of somebody living that long and what that would mean. That person's age would be an example of an outlying score. So imagine if you took a random sample of people and wanted to calculate their average age or their mean age, and that guy was in the sample. What would that do to your mean? What would that do to your average? It would make it higher than it probably should be. It wouldn't reflect reality very well. So the mean, advantage and disadvantage. The advantage is that it uses all the data, and the reason that's an advantage is that means that we can carry that number forward into other calculations. The disadvantage is that it uses all the data, which means as a statistic, it's sensitive to outliers. I'm going to keep these segments short, and so I will upload this and then follow up with our additional measures of central tendency and measures of dispersion variability.